Let's solve some trigonometric equations. I look at this one and I realize I have cosines and I have sines in it. I would like to have just one trig function in there. So I'll use the Pythagorean identity to replace cosine squared with 1 minus sine squared. Now I have something that looks like a quadratic equation. First, I'll just get rid of my parentheses. I will combine my like terms. And since I'm not a fan of having a negative leading coefficient, I'm going to switch everybody's sign. Just multiplying both sides by -1. And now I have something I can factor. We could multiply 2 times 2 and get our grouping number, but I think this one is simple enough for us to guess and check. Because the only way we can get 2 as a product is to multiply 2 and 1. We need -5 to be our middle term. Oops, and that should be negative. Let me erase that. Because a negative times a negative gives me a +2. And then outers gives me -4x, inners gives me minus sine x. So I end up with exactly what I need. So now I have two little equations I can solve. 2 sine x minus 1 is equal to 0, or sine of x minus 2 is equal to 0. If 2 sine x minus 1 is 0, then sine of x is equal to 1/2. So in the interval from 0 to 2 pi, I would have the solutions x is equal to pi over 6, or 5 pi over 6, and sine of x equals 2 has no solution, so we get to put the big X mark through it. So I have my solutions in the interval from 0 to 2 pi. If I'm asked for all solutions, it would be pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k. Another trig equation where we are taking the trig function of a multiple angle. So first thing I think I'll do is add 2 to each side and isolate my trig function. And then I recognize the fact that secant is 1 over cosine, so if secant of 4 theta is equal to 2, then cosine of 4 theta is 1/2. So I have a couple of possibilities. 4 theta could be equal to pi thirds, and I want to go ahead and add my 2 pi k, because at this point I need to divide both sides by 4. So theta is pi over 3 times 4, which is 12, plus 2 pi over 4 gives me pi halves k. My other possibility, in addition to pi thirds, cosine is also equal to 1/2 at 5 pi thirds. And that's 4 theta is equal to 5 pi thirds plus 2 pi k. So theta divide both sides by 4, would be 5 pi over 12 plus pi halves k. So if we're asked for all of the solutions to that equation, we are done. Now generally we would like to have the solutions that live in the interval from 0 to 2 pi. So I'll start with pi over 12, and I'm going to add pi halves to it. So pi over 12 plus 6 pi over 12, which is pi halves written with a common denominator, would be 7 pi over 12. So I'm going to go ahead and write my 5 pi over 12 because I like to keep them in ascending order. So I have 7 pi over 12, and then I will add pi halves to 5 pi over 12, and that will give me 11 pi over 12. I add another pi halves to 7 pi over 12. I get 13 pi over 12. I add another pi halves to 11 pi over 12. I get 17 pi over 12. I keep in mind that as soon as I get to 24 pi over 12, that's going to be too big because that's 2 pi, but I can add one more pi half to each one. Pi halves plus 17 pi over 12 would be 23 pi over 12. And these are all the solutions in the interval 0 to 2 pi. You notice instead of 2 solutions like we would if it were simply cosine of theta, we get twice as many. We get 4 times as many because we had 4 theta.